In previous video, we saw that the wave equation, which is second order wave equation, is hyperbolic. You can prove that from the theory of partial differential equation. Let me just discuss one more very important topic before going to the detail of finite volume method in the upcoming videos. Just to remind you, until now, we are just giving a brief summary of different topics, of different content that we use in finite volume method. The conservation laws is one of that topics that require attention in finite volume method. What do you mean by conservation laws? Conservation laws mean that we are talking about conservation of mass, we are talking about conservation of momentum, so on. Conservation of momentum and conservation of energy and conservation of charge, so on and so forth. These are the theoretical definition of mass and momentum and some angular momentum, so on. Energy, conservation of energy. How do we write conservation laws in mathematical form? And we will see in future that when we write equation like this, partial q by partial t, partial by partial x, f q x t, then that form is called the conservation law. Okay. So conservation form, we call it conservative form. There is a reason. The conservation means that something that remains preserved. There's no change when the system is closed. Conservative uh, form. So what is, if this is conservative form, then what is non-conservative form? The non-conservative form is written like this: partial q by partial t, f dash q partial q by partial x is equal to 0. Here we applied a chain rule. F is a function of q and q is a function of x. So we take first derivative partial f by partial q, then we apply the second derivative, first derivative of q with respect to x and multiply these two. So this is the non-conservative form. What happened is, in the first case, we have written equation where the flux, in future we will see that this f is called a flux. This flux is written inside of a derivative. In the second case, we have a quantity which is written, some part is written outside, just to memorize it, just to remember that, and the individual quantity is written like this. This is called, the second one is called non-conservative form. When we have a scalar equation then there is no need of any matrix. But when it is a vector quantity, when the equation is written in vector form and in non-conservative form, then this coefficient matrix is called a Jacobian matrix. Jacobian matrix. What is Jacobian matrix? Jacobian matrix is a matrix containing only first order derivative, partial f, q, x, t, and with respect to some other variable, for example, x, so on. So these are all first order partial derivative. For example, if you want to see the Jacobian, you can search it as well. But here, if we have, for example, x is a function of uv and y is a function of uv, then you can take first order partial derivative, partial x by partial u, partial x by partial v, and similarly partial y by partial u, partial y by partial v. So here we have all the Jacobians, all the first order partial derivatives in this Jacobian. So this term is called Jacobian when we have system of equation, and here we have written it only for two variables, and in short we write it like this: x u v, and with respect to partial uv, something like that, x y, for example, something like that. Okay, so this is the Jacobian matrix, and this is a non-conservative form. So it is important in finite volume method we distinguish between conservative and non-conservative form. This actually does not happen in finite difference method. In finite difference method, we blindly work in the equation without distinguishing it into the conservative form or non-conservative form. So this was all about the conservation laws. Thank you for watching.